All right, so I got a question on the monitoring progress questions. So what I'm going to do is I'm going to take a look at monitoring progress question number 3. All right, so it says solve the system of linear equations by graphing. Well, so literally graphing is just using what we know about the equations to plot the line, right? We've learned a couple different ways. You could use key characteristics. So if you remember the type of equation that you're being given and what's easiest to find from that equation, you can use that to graph your line. Or you could make a table and plot points, right? An input-output table and plot points. Those are the two main ways that we discussed graphing. It's a little faster if you can remember key characteristics. So for example, this first equation I see is in slope-intercept form. Y equals 1x minus 2. So I'm going to put a point on -2, and I'm going to use my rise over run, up 1 over 1, to plot another point, right? Up 1 over 1. And you can kind of check to make sure your graph is plotted correctly by looking at additional points. Then my next equation is y equals -x plus 4. So I'm going to go to my y-intercept at 4, plot a point. I'm going to go down 1 to the right 1 and plot another point. And I've got my second line. And now I can see that my intersection of my two graphs is at 3, 1. So I know that my solution is going to be 3, 1. And that's how you solve a system of equations by graphing. Okay. We can check our work, check it. What do you think? Let's see what the check button does. Oh, and it liked it. It liked my solution. Okay. Remember, let's see, question number 4 is in slope-intercept form. Question number 5, they're using standard form, right? So in standard form, remember, standard form is the form that doesn't tell us any nice key information just by looking at it. So we have to do a little extra digging. So from standard form, we want to make our table, our input-output table, and we want to remember the key characteristics that are easiest to find are going to be the intercepts, right? So I make a table where I'm going to plug in 0 for my x, right? So I know y is going to equal 5. My pen catches up with my my computer's like not reading my pen for some reason. 5. Let's see here. Okay, and then we would, so for time's sake, and then we would also plug in 0 for y and figure out what there we go. Okay. Of course, it all caught up at the same time. All right, there we go. Okay. So equals 5. Oh, now it's going to do it again, of course. Y equals 5, and I can put a 5 right there. And then I would do the same thing for the same equation, right? Except I'm plugging in 0 for my y to find my x value. So 2x plus 0 equals 5. So 2x equals 5. Divide both sides by 2. Uh-oh, it's thinking. I wrote a whole bunch of stuff. I didn't wait for it. X is going to equal 5 halves. If it ever shows up on my screen. So not the easiest point to plot, 5 halves. Okay, there we go. 5 halves is not necessarily the easiest point to plot, but you can do it, right? If you don't like that, you can always convert into slope-intercept form. That might even be easier for this problem. And then use your slope to help you plot your y-intercept, use your slope to help you plot additional points. Once both lines are graphed, then you want to look for the intersection and that'll tell you your solution. Your solution